When it comes to the question how to test in Angular that I'm going to answer in this video, then we have to say with Angular we are a little bit in a special situation, because the Angular CLI, whenever we generate a new file, automatically also includes a testing file, which means that Angular kind of tries to recommend to write a testing suite per file that we have, service, component, etc. Modern testing, which we know from the industry and which also has already been confirmed by the Angular team itself, is not about this anymore. With modern testing, we should try to have one test that covers maybe multiple files. That's the target. Now in this video, I will go through all the different testing types. I will explain their pros and cons, and then I have also prepared an example to showcase a typical modern test, so to say. This video is not about the testing tools. This is then part of a separate video. Here it's really about only the testing style itself. And by saying that, welcome to this video. My name is Rainer Hanekamp. I'm a trainer and consultant at Angular Architects. So we provide workshops in the area of Angular, obviously. And I would say, let's start. All right, so before we start, we have to make sure that we speak the same language. So if I use a certain testing term, that you have the same understanding as I do. The issue in testing is that the testing terms, they are not really specified. There is not really a dictionary which I can look up. So I have to kind of provide you my terms that I'm going to use along with their definitions. I usually follow the terms which we know from the testing pyramid. So the testing pyramid is a very old model, an old testing model, which says we are going to focus on those kind of tests where we know that they are run fastest, which we are going to challenge. But let's quickly go through the testing definition. So we have the unit tests, the integration and component tests, which in a way are very similar, and then we have the end-to-end tests. So when I speak of a unit test, especially if we then also look at Angular, then I would say I have a component, I have a service, doesn't matter. For me, the thing that I want to test is the class, is the TypeScript class. I don't care about the template, if there is one. So I'm only calling methods of my class. And if I want to assert something, I'm always asserting against the properties of that class. When it comes to the dependencies, I'm going to mock all of them. So I'm going to replace them with test tuples, however you want to call them. But the important thing is that I'm not going to use the original dependencies. That's a unit test. If I say I write a component test, then it's kind of like a unit test when it comes to the dependencies. I still try to replace them with mocks or whatever, spies, fakes. But when it comes to the communication with my component in this case, then I say I'm not going to call methods, I'm not going to assert against properties, but I'm interacting with my component via the DOM. So I'm clicking on buttons and then I'm asserting against things which are rendered in the template. This is my surface, this is my testing API, so to say. And then we have the other part, which is the integration test. And if I say integration test, then I mean very similar like a component test in that sense that I'm communicating via the DOM, but I'm not trying to replace all the dependencies. It's actually the opposite. I try to use as many of the dependencies that I have inside of my test. There are of course some restrictions. I can't kind of say I want to include all the dependencies, because as soon as my application starts to send out a request, I don't want to kind of use the original one, I want to mock that. And even if you have also a very large application, then it's not just about mocking HTTP requests, you will also mock other things. For example, you have a user service that kind of connects to Keycloak or something else. Well, in this case, you are not starting to mock the HTTP requests that go out to Keycloak, you are mocking the user service itself. So that's the way how an integration test works in this case. And then I have my end-to-end test. And with an end-to-end test, it's a different story. First of all, it's a different technology. Again, this is not part of this video here, but my test does not really care if there is an Angular instance running, if we have React, if we have old school server-side rendering from a backend framework or whatever. My test says, okay, look, there is a web application. That is what is important to me. I'm going to open your application and I'm going to communicate, to work with your application as a real user would also do it. This is what an end test is doing. It doesn't care about the concept of a component at all. With end-to-end testing, there is always this question, is the backend included, is it not included? It's this, in the end, both variations are valid end-to-end tests for me. Just a general piece of advice, if you can include the backend, then please do it. Your test gets much more value out of it compared if you're just testing the front end and nothing else. Good. So we will now start with a unit test, an example of a unit test. Then I will do an integration test, another version, and then we will hopefully see a difference. And then comes another part where I'm going to discuss the advantages and disadvantages of the different approaches. So I have here my application where I want to test a certain feature. I click here on holidays and there is a certain quiz feature. So as we see, it's a normal quiz about Norway. And we have here obviously questions. So if I click on a question, it tells me if it's the correct one or not. Then we also have here a countdown and well, that's it for the quiz. If we go to the source code, go here, then we see that our quiz consists actually of quite a lot of things. So we have, first of all, we have here our quiz component. This is one file. And the quiz component is a classic container component. So it delegates the task of rendering to our UI components. In this case, that's the quiz status and that's the quiz question. And when it comes to the logic, it also doesn't do that much because it's using here a quiz store for it. So it's again delegating the logic here to a particular service. So it's kind of managing things, kind of fetching the data and then providing it to the UI components. The UI components, so we have the quiz question component, it's a classical UI component, a little bit of template, but not that much of TypeScript as we see here. And the same is also true when it comes to the quiz status. So also here, it is just using inputs and focuses mainly on the template. The quiz store itself is done with the signal store, ngrx signal store. Yeah, so far so good. So this is where all the logic resides. And the quiz store is also using something else, which is a quiz service. And this is what you see here. So the quiz service is responsible for connecting to the backend, fetching the data, but also to map the API type to the correct type that my application needs. You can also say it maps it to the view model. That's what we have here, this toQuiz function for. So if I click on it, then it says, yeah, so a function, a typical mapping function. And we also have here, of course, the model where we have all the interfaces located. So a bunch of different files. Now, if I would now say, I want to write a unit test, I want to test my application via this unit testing style, then again, this means I am only focusing on one file and I'm testing only the TypeScript part. And if we would now go to quiz component, and I would say, okay, I'm going to start with the quiz component first, then I would open here the spec, and I would then say, okay, what do I actually have to do here? Because here on the left side, we have now our quiz component. What are the dependencies that I need to mock? Well, first of all, what I want to mock is that I don't want to use all the visual dependencies. So I want to disable the complete template, which means whatever happens here, that's not my concern. So I will not call the quiz status, I will not call the quiz question, they are all mocked. maybe not just even mocked. So the only thing which I really require is a quiz store title signal. That's one thing. The other thing is that I obviously want to call the quiz store set ID and also quiz store answer. So these are two methods that need to be available. In the end, it comes down that I only need to mock one, that I just need to mock one thing, and that's the quiz store, and I need to mock the three different properties / methods. So I'm going to do that. I'm going to say, okay, you know what? We have here our quiz store. Let me activate Copilot because it's not that hard to do. And I'm going to say, okay, there is this title. It has a signal which says, yo, I'm a quiz. And then I have my set ID where I say it's not a chest function because here in this case I'm using chessmin. But if you would use chest, then of course you would say chestfn. In my case, I just say create spy, say here set ID, and then I have also answer where I also say chessmin create spy answer. Now this is now my replacement for my quiz store. And I need to inject that one now into my testbed when I set up my quiz component in that case. I have to use the testbed in this case because I'm using here the inject function. So although I said before I don't want to use that many things of Angular, I'm trying to mock as much as possible. The testbed is something we cannot avoid if we are using the inject function. And by the way, that is also recommended by the Angular team. There is a GitHub issue where you can then read if you want, where there is an explanation why the testbed is so important and why you should use it. So I say testbed, configure testing module. The problem, I will not come that far with the testing module in this case, because I need to override the providers from the component. So I could here override globally provided services, but not component provided ones. That's why I need to use something else. I need to go with testbed override component. I'm going to override my quiz component, obviously. And then I need to say, what do I want to override? Now I want to set certain things first of all. So I say, okay, I want to set the providers, as we see here. And I want to provide, in this case, my quiz store. And I want to say here, please use the value that I've just provided. First thing. Second thing are the imports that we have here. So I don't want to use these imports. I want to replace them. As a matter of fact, I actually don't want to use any of them. I don't even want to provide test doubles. So that's why I say here, it's an empty import. And because then Angular would start to compile if it would create the component, we also have to disable here the template check. As I said, I'm not interested in the template. So I just say here, we have our schemas, and I say no error schema. This is the one that I want to use. Now I have overridden my component, and now I can create it. So I can say here, create component, quiz component, which will now generate me a so-called component fixture, which also contains the instance of the component. So I say here fixture, and if I want to access now my TypeScript instance, then I say component equals fixture component instance, like this. And now I can start with my test. So what do? Well, I say, I click here on an answer. So if my user says here, click on the answer, then the handle answer is called. And I just want to verify that the quiz store answer gets the right question ID and the choice ID. And again, I don't click on the button. There is no template for me inside of this test. So I'm saying here component, handle answer, it should be 1 and 2. And then at the end, I'm going to my quiz store, which I have already mocked. And I say, you know what? You should have been called, the answer method should have been called with these parameters, 1 and 2. That is important to me. Now I save it, going back to my test, check if it's still working. Yeah, reload the site, looks good. Let's do the opposite. Let's say here we have number 1. Yeah, test is going to fail. Wonderful. So the test is working as it should. In the same manner, I would now continue, because I could not say, okay, I have tested, as a matter of fact, all the code which is there. Everything has been executed, and I would now focus on the next file, which is not the quiz store, but which is the quiz service. So if I say here, what's the quiz service? What is it doing? So we have here our quiz service. Well, not that much. You open it here. It just has a find by ID. And well, I need to do the same thing again. I'm going here to mock my HTTP client. I'm executing find by ID. And then in the end, I verify that the HTTP client has received the right values in this case. So I say here, okay, I have my HTTP client. I say I will call the get method. From there, I need to use a spy in this case. Let's call it get. And then I am going to instantiate my service. So again, I say testbed, configure testing module. Configure testing module. In this case, the HTTP client is a globally provided service. So that's why I need to override it here in the testing module. So I say here providers, I say provide HTTP client, and then I say use value my own HTTP client. And then I'm going to instantiate my service, not via create component, but via inject. So I say here, I have my quiz service. This is the one that I want to have, right? And what comes next? Well, I need to define what my HTTP client should actually do. So my HTTP client needs to say when I'm called with the get method, then I need to return a certain value, because otherwise my service will have some issues, and that return value should be an auth. And now, of course, we always have to take a look at the response types that we have there. So there is this quiz API. So if we would say here, okay, we have ID, title, time in seconds, and questions, that one should be enough. So I say here, it's an object literal, where I say I have an ID of 1, I have title quiz, then I have my time in seconds, which is 1660, and well, this should be already enough. Yeah. And then, as it says here already, I'm going to call the find by ID, not in the way as the Copilot is doing it here. I'm just saying here's find by ID. Let me close that one. So find by ID number 1, and then I just verify that the HTTP client was called. So I say here, expect HTTP client to be called with. And I say, okay, you should have been called with number 1 in this case. So again, of course, so we have to say here, holiday quiz, the ID is included here in this string. Next try, and now it's finally working. Yeah. So these are these kind of unit tests. And if you're working in a company or in an environment where code coverage is important, then of course we can also now measure it. So I can go to my package.json. There is already here a script which says test CI, which covers the code coverage as well. I'm going to run it. We are getting now a report. Open in browser. And the report says, in your holidays quiz, you have a 100% coverage of quiz component, quiz service TS. So I would say, well, job done, wonderful. The question is, Do you actually really trust your tests now? Or would you say, yeah, code coverage is good, but I'm not sure if I'm doing the right job here, or if those kind of tests actually make any sense or give me back some kind of real value. And this is now where the other testing type, and I would say we will go to the integration test, becomes an important aspect. So I have now prepared an integration test. I'm not going to write it because it will take a little bit longer. And there is also the question of the technology that you're going to use about the tooling. In this case, I've been using the testing library together with Jasmine. And as I said, there are other tools available as well. You can use, for example, Spec Data, or Cypress component testing is also available. So there are different tools. But the point here is, the important thing is that I'm going now to have one test which covers the quiz component. So I'm clicking on an answer and I'm verifying if the right answer actually shows up. And I'm doing this by not mocking any of its dependencies. The only thing that I'm really going to mock is the HTTP client. But everything else is included, and I just write one test for the complete feature of quiz. Let's quickly go through the code. So we have here our testbed configure testing module. I'm not overwriting anything of my quiz component. That's why we don't see here any testbed override component. Since my quiz component depends on the router, and it says there is an ID in the router which tells me which kind of quiz I have to load, we are also including here the so-called router testing harness, which means I don't need to mock property binding of components. I don't need to mock router link directives or the route or activated route service. They are all there. But what I have to do instead is that I have to then provide some kind of routing configuration to my testbed, and I say here, well, the quiz component is linked to this path. Doesn't have to be the same path as it is in the application, but it should be one path, and the important thing is that we have here the property binding of the router information with the ID. As it says here with component input binding. Location box is also necessary if you do that, if you use the router testing harness, and then of course I'm going to mock my HTTP client. In this case, I've opted for not creating a manual mock fake. I am going with what Angular provides me, and that's the client testing. Then I'm going to inject here my testing controller, my HTTP testing controller, which allows me to take over control of my HTTP requests. And then what we see here is something you will not see in the official documentation. This is tooling specific code. So as I said, I'm using here the testing library, and the testing library provides me plugins, which allows me to do communication via the DOM in a very close way as real users would also do it. So this is what user event is doing here. Then I'm starting my actual test by using the router testing harness. I'm going to navigate to that URL. I'm not going to call to create the component. I'm really navigating to it, and I'm providing here the ID 1. I'm also enabling automatic change detection. That is important. And I know that now my quiz component should send out the request for this quiz. And that's what I'm going to match here with my HTTP controller, and I'm returning a predefined full-blown quiz that contains already some answers, some questions, and some predefined answers. And then, as you see here, I'm doing one final verification before the actual steps of the test starts. And this is here find by text. So I say on my screen where the component is rendered, I want that somewhere Angular quiz should be shown up. And this is for me the criterion to know from now on I can start doing the test. So what this test is doing then, it really, as you see here, await user click. So this is this API from the testing library. It says I'm going to search here, first of all, for the question, what programming language is Angular written in? And then I'm looking for a question. I use a get by text, where I say it contains the name, the text, TypeScript in it. And I also click on it. This is what we have here. And then what should happen? Well, there should be somewhere status information, text blocks in my application. We have seen it before. And in this case, I have here some kind of predefined UI, correct status, functions, finder functions that return me the DOM element. And there I say, well, if I click on the right answer, it should say status correct is 1 and incorrect is 0. Almost like a real user would test it. I don't care if I'm using the signal store, if I'm using UI component, if the signal store is using a quiz service, if everything is done in the quiz component, I don't care. I say I just click on the right answer and I want to see that the status updates correctly. This is this approach of those kind of integration tests. And if we would now say, okay, and what about the test coverage there? Yeah, we can check it out. Again, remember, there is just one test that I have written. I mean, one test suite. There is one test that checks if the question is shown correctly, one that shows if I'm answering wrong, if the status also updates correctly. And then I have here my timeout because I also want to verify that my countdown is also working correctly. So the coverage is already done. This is the coverage that we had before with our unit tests. Now I reload it and you see all of a sudden we have an extremely high coverage. I have in the meantime also disabled the unit tests before. So what you see here is only coming from that single testing file which I have just shown you. And the reason for that is that my feature quiz is not so complicated. It doesn't have so much logic. It's always straightforward. I'm loading data, I click on something, it says if it's correct you do this, if it's not correct you do that. There is also the countdown, but that's it. Of course, split up into multiple files, yes, but there is not so much logic, as I said. And my integration test covers now all of it. And now the question is, well, what should we choose? And you might not be surprised that the current, as I said before, that's not my opinion, it's also been confirmed by Angular. You will see it then later in this video, but we also know it from the industry that there is now this trend that we should favor those kind of integration tests over the unit tests. They bring us more value, and given we don't have so much logic, they are just more efficient. So we have here two models that I would say they really represent how modern testing should look like. We have here on the left side the Spotify honeycomb, which is actually coming from the backend, but it was just important to me to show you that even in the backend, where we have actually quite a lot of logic, the testing pyramid is not state of the art anymore. So we say here, the honeycomb says it should be more, the testing should more focus in the middle. On the right side, you see Kent Dodd's the testing trophy, which is very famous. It was originally invented for React, I guess. So what he's saying, if you use TypeScript, static typing, that you don't need to write unit tests for type checks. I think that's clear for us as Angular developers. But in the end, it's also the focus on the integration tests, not so much on the unit tests. Because again, the reason is unit tests, if you don't have logic, and like if it's like with this quiz store, where I said, what do I want to test? I have a service which is just calling an HTTP client, and I'm only testing this thing. What does this give me back? Not that much for the time I need to invest. We are much better off if we focus on those kind of integration tests first, where we say we cover the whole story, the feature, and then we can, for example, use code coverage tools to find out if there are some empty spots that we might have missed, and these are then maybe candidates for unit tests, so to say. End-to-end test is here also small. Why is that? Well, end-to-end test is great, yeah, so don't get me wrong. End-to-end test is really something, and it's still questionable if it might not become a bigger part in the future. But with end-to-end tests, we have two issues. We have, first of all, the issue that they tend to be very slow. And the second one is that it's very hard to set up the infrastructure. So end-to-end test usually also contains the backend, and this is not easy to do, to have a testing environment with feature branches that you say, okay, now you boot up the backend for this one, you boot up another backend for another thing. That's not easy. And I don't even want to talk about the database, because if you also include the database, which naturally will also be part of it, then you have some issues with your tests, because every test is changing something in the database. So the test seed is going to change over time, and all the tests, they need to be aware what the other tests have been doing before. Because maybe a quiz, which used to be called Norway initially, is not about Norway anymore. It's now for a different country, because some tests just renamed this test, this quiz. Let's quickly take a look at the advantages, pros and cons of those unit and integration testing styles as well. So here, first of all, we start with the definition of unit test that I used before, where I say unit is actually a class. So this means I'm going to mock everything which is not part of this class, which means I'm very tightly coupled to the implementation. That's clear. I need to call the methods. I need to know exactly what kind of properties are. In terms of mocking, I also need to know how which methods of the dependencies are called, because I need to re-implement them. There are some disadvantages with these kind of tests, and the major one is we cannot really do a test-driven refactoring. That's the problem. So you can't say I'm going to refactor now my feature. I'm going to add now maybe a new UI component. I'm going now to split this quiz store into multiple services. You can do it, but you also have to change your tests when you do this refactoring. So when you are done with the refactoring, you have no guarantee anymore that your application is still working as before, because your tests can't tell you this anymore. This is a major problem. You're coupled so much to the implementation. There's usually also a lot of code necessary for the mocking part. Yes, depends on the way how you do it. If you have smaller classes, then maybe it's not that much. But if you have a service which contains 10 different services, obviously you have a problem. And you never have this interplay testing. So you never can be 100% sure that maybe a component, which is calling a subcomponent, if property binding works, if the event dispatching works in the right way. This is something which you just don't know. And also the maintenance is a big problem, because you can write unit tests very easily. They don't take so much time compared to an integration test, but you have to maintain them. So it's not like only the writing, it's also whenever you do some changes to your code base. And as I said before, unit tests require quite a lot of changes when you do something in the implementation. You also have to maintain them. That's not easy. It's actually a little bit frustrating, to be honest. Advantages. With those kind of unit tests, you can do this kind of edge case tests. You can very easily find bugs, because you can kind of focus on a certain area. That's really a nice thing. And if you, for example, have a certain service and you expect that there is a bug in it, with a unit test, you can only test the service, also define the context, the way how the dependencies should behave. That's really nice. Great code quality, yes. So if you use this, then you will see you will end up with having very smaller classes and that stuff. That's true. And of course, unit tests, they are very fast. Saying fast, we also have to say that integration tests also tend to become fast. In the past, we had an issue in Angular because of the compilation. Also, there was a memory leak, but this has been all fixed by now. So this kind of argument, unit tests are faster, is still true, but there is not so much distance anymore than it used to be. The integration test, and again, this is what I define as an integration test. There are some people out there which call actually the integration test unit test, and they don't really have this concept of a unit test where they are focusing only on one class, for example, the Angular team, because they say, well, this is not necessary. I'm testing a behavior. I'm mocking those things that I have to mock, which are not really part of my feature in this case. or which are very hard to include. So we always have to be careful about the dependencies. The best thing is, as I said, with an integration test, to include as many as we can, but from a practical side, that's not always possible. We always run against an API, which means in Angular, it will be very likely a component, not a service, not the UI component, but a smart component, which is directly linked to a route. This is the most common case, and that one will then include all the other things. The obvious advantages are now that I can do a refactoring. So as I said before, I can split up my component. I can split up the logic if there is one, and I don't need to touch my tests. With the quiz, for example, I say a question should be shown, there should be an answer button, I want to click on it, and I don't care what happens internally, what services, what components, what directive pipes are necessary in order to fulfill this process. In terms of coverage, we have seen they are also very efficient. And again, this efficient only holds or stands true if we don't have so much logic. And at this point, I think I want to highlight it. This is how you test this kind of statements. They are always dangerous because there are different types of applications. But for the mainstream applications that I know, where all the logic is part of is located in the backend, and our frontend isn't doing that much, this kind of strategy applies quite nicely. Also, when it comes to code to efficient testing, that still is true. If you have a special application where I say, no, I have a lot of logic, then of course it switches, because then unit tests are also becoming very important, not just integration tests, but you will just have a much higher range of testing techniques that you have to apply. But in general, integration testing is the thing you want to go to. There are also some disadvantages. Yes, the setup is not that easy. True, this is true. We have to invest a little bit of more time in setting up the test bed. Yes, but we don't write so many tests. That's the flip side. They are slow. Yes, that's also true compared to unit tests. And the last thing is, depending on the tooling that you use, they can be very hard or they can be relatively easy. Now, they are definitely very hard if you don't use any tools at all. So if you say you're just using Jasmine Chess, depends on whatever you're using, and you're using it as it is, for example, described in the Angular documentation, then you will have a very hard time. You have to deal with asynchronous tasks. You have to deal with change detection, although this is being improved at the moment. Then you also have to deal with certain DOM events that you maybe have to dispatch manually. So again, integration tests, yes, please try to do them. Please try to favor them over the unit tests, but use tooling for it, an additional tooling for it. That is important. And again, if you now ask, okay, and where's the end-to-end testing in this picture on this slide? Well, again, end-to-end testing is something you should always do. It is even better than integration test in that sense that you're not so dependent on the implementation. You can actually replace Vue React.js with Angular if you want to, and you don't need to change your end-to-end tests. With integration tests, it's of course a different story. But with end-to-end tests, you should do them again, but you will have a certain limit. There is a certain border where you cannot continue anymore, being it from the amount of tests with the database, being it because they tend to be much slower. And that's why the most of the time that you should invest is with integration tests, because they can also scale. They don't depend on each other that much. Last thing about testing tools. Again, I've said that I've shown you that I use the testing library in my case. There is also Spectator. There is also Cypress component testing for Angular, which is even better than the testing library. But there will be a different article, a different video from me about the tooling itself. That's not part of this video. This is really about what style of testing should you prefer. And I think by now it should be clear that for the mainstream applications, integration test is the way to go. Now, before we finish, some questions maybe about the future. I mentioned Cypress component testing. So we see that from the tooling, the end-to-end testing tools are becoming much, much better. And well, I don't know. I mean, given the speed of end-to-end tests, for example, if we look at Playwright, we see that end-to-end tests are becoming more and more important because it's more easier to do them. I don't know how the future will be. There is still this big question mark with the testing couple for end-to-end tests, but I don't know how it will look like in 5-7 years, what the situation of end-to-end testing will then be. Maybe it will become a more important part, but for now, it's still integration tests. Now, before we end, I want to show you some outtakes of a video of the Angular Q&A session with the main headlines or with the main takeaways from Jeremy Elbourn, who is the tech lead of the complete Angular project. And in this session, he explained also how to test.
You want your tests to be as representative of real life as is practical, right? And some things are not practical in test, right? Making real network requests to your server, that's not practical in test, right? That's going to make your test flaky. It's unnecessary. So, you provide fakes for those things.
But you know what this reminds me of, though?
Mm-hmm.
Integration tests almost. How like integration tests actually go through and like click through things and, register the click events. I know it's not exactly like that, but open, then it check the values, right? Like that reminds me of an integration test style.
Yes, it is much more aligned with the way people have historically written integration tests. The different types of testing doubles and when you should use them and what they're good for. A test double is anything that exists only in tests that you're using instead of the real implementation. And there are two types of test doubles that developers will commonly use. One is called a mock, and one is called a fake. What I'm creating right here with this Jasmine spy, this is a mock. A mock is something that keeps track of the APIs that you're calling and when you called them, how many times you called them, what parameters you set when you called them. Mocks are generally very brittle because all mocks are doing are asserting that your code does what you wrote it. It does, your code calls the functions that you wrote your code to call, not that it serves the purpose that you meant your code to serve. You would mostly create fakes when the API that you're using is not practical to use in a test. So the hierarchy is use the real implementation when it makes sense, when it's practical, use a fake when it's available, or sometimes if you have to create your own, that's unavoidable, but a fake is usually better than creating a mock. And only use mocks is really a last resort when you have no other options. If you are refactoring your code and the behavior stays the same, it's not doing anything new, it's not doing anything different. If you cannot change your tests, that's a victory. It means your tests are not brittle and that your tests are actually checking that the code does what you want it to do instead of just being a snapshot of the particular way you wrote that code.
Yeah.
So I think there is nothing else to say. Again, I want to highlight that this video was not about the different tools which are available, but really about the approach. So for example, we also have Cypress component testing, which we could use for the integration tests. If you have been so far somebody who has written those kind of unit tests, then I would really recommend you to try out the integration test, and you will see the value that you will get back and you will get to enjoy testing, hopefully. That's it. If you have any questions, any comments, then please just ask. And other than that, thanks for watching and see you in the next video. Goodbye.